A small can of condensed milk doesn't look like anything extraordinary. It sits quietly on supermarket shelves, inside kitchen cabinets, or on the counter of a busy bakery. Yet inside that simple can is something surprisingly engineered. Because condensed milk doesn't start thick. It actually begins as ordinary fresh milk, a liquid that is mostly water. And turning that thin, fragile liquid into a rich, dense, shelf-stable concentrate is far more complicated than most people imagine. Inside large dairy factories, fresh milk arrives in massive refrigerated tankers straight from dairy farms. It's tested, filtered, and stored in giant stainless steel silos before it even begins its transformation. Then, the real process starts, a process that involves dairy science, engineering, and extremely precise control over every stage of production. So stay with me until the end, because once you see how factories remove the water, control the sugar, and concentrate the milk, you'll never look at a simple can of condensed milk the same way again. Every batch of condensed milk begins far away from the factory, at large commercial dairy farms where fresh milk is collected every single day. Modern dairy farms use automated milking systems that gently extract milk from cows while maintaining strict hygiene standards. The fresh milk immediately travels through sealed stainless steel pipelines that prevent outside contamination. But fresh milk is extremely delicate and can spoil quickly if it isn't handled properly. That's why the moment it leaves the cow, the milk is rapidly cooled to about 4 degrees Celsius to slow down bacterial growth. The chilled milk is then stored inside massive insulated cooling tanks that can hold thousands of liters at a time. Inside these tanks, slow mechanical stirrers keep the milk moving so the fat does not separate from the liquid. Once enough milk has been collected, refrigerated tanker trucks arrive to transport it to dairy processing factories. Before loading the milk, technicians take samples to test its fat content, acidity, and overall quality. Only milk that meets strict industrial standards is allowed to continue toward the condensed milk production line.
But even after arriving at the factory, the milk still isn't ready yet, because the next stage determines whether the final condensed milk will be smooth or completely ruined.
The quality check that decides everything. When the tanker trucks reach the factory, the milk goes through another round of strict laboratory testing. Technicians collect fresh samples directly from the tanker compartments before any milk enters the production system. These samples are carefully analyzed for bacterial levels, protein content, fat percentage, and potential contamination. Even the smallest impurity can affect the stability of condensed milk during evaporation. If the milk passes all tests, powerful pumps transfer it from the tanker into enormous stainless steel silos. Some of these silos are tall enough to store tens of thousands of liters of raw milk at once. Inside the tanks, the milk remains chilled and gently circulated to keep its composition consistent. This controlled storage ensures the factory always has a steady supply ready for processing. But raw milk from different farms never has exactly the same fat and protein levels. And that variation can completely change how the milk behaves during evaporation.
So before anything else happens, factories must first rebalance the milk's composition with extreme precision.
Balancing the milk's hidden chemistry. At this stage, the milk is carefully standardized to achieve the perfect balance of fat and solids. Factories use powerful centrifuge separators that spin the milk at very high speeds. This spinning motion separates the heavier skim milk from the lighter cream. By adjusting how much cream is mixed back into the milk, technicians can control the exact fat percentage. This step is critical because condensed milk requires a very specific composition to thicken correctly. Too much fat can cause instability during heating, while too little fat can affect the final texture. Sensors continuously measure the milk's density and composition during this balancing process. Automated control systems adjust the flow of cream and skim milk in real time. The goal is to create a perfectly consistent liquid
that behaves predictably during the next stages. Once the composition is correct, the milk is ready for purification. Because even tiny particles hiding in the milk could destroy the smooth texture condensed milk is famous for.
Because even tiny particles hiding in the milk could destroy the smooth texture condensed milk is famous for.
Cleaning the milk to absolute purity. Before the milk can be heated, it must pass through several powerful filtration systems. Industrial clarifiers spin the milk rapidly to remove dust, dirt, and microscopic debris. These machines use centrifugal force to push heavier particles away from the liquid. The result is a much cleaner and more stable milk base. After clarification, the milk flows through extremely fine stainless steel filters. These filters capture any remaining particles that could affect flavor or texture. The milk now becomes smoother and more uniform in structure. But cleanliness alone isn't enough to prepare the milk for condensation. It also has to be made completely safe from harmful microorganisms. That means the next step involves carefully controlled heat treatment.
Because without this crucial heating stage, the milk would spoil long before it ever became condensed milk.
To eliminate harmful bacteria, the milk is heated inside large industrial pasteurizers. These machines raise the temperature of the milk to carefully controlled levels for a short period of time. The heat destroys dangerous microorganisms while preserving the milk's natural flavor. Sensors constantly monitor temperature to ensure the process remains perfectly balanced. If the milk overheats, its proteins could break down and damage the final product. If it doesn't heat enough, bacteria could survive and spoil the batch. After heating, the milk is quickly cooled again to stabilize its structure. This process ensures the milk is both safe and ready for further transformation. At this stage, the liquid still looks exactly like ordinary milk, but that is about to change dramatically.
Because the next step introduces the ingredient that turns simple milk into sweet condensed milk.
Unlike evaporated milk, condensed milk contains a large amount of sugar. Factories prepare a concentrated sugar solution that will be blended into the milk. This syrup is heated and filtered before entering the production line. Precise pumps then mix the sugar solution with the prepared milk in controlled proportions. Sugar does more than add sweetness to condensed milk. It also acts as a natural preservative that prevents microbial growth. By increasing the concentration of sugar, the mixture becomes more stable and shelf-safe. The blending tanks continuously stir the mixture to keep it perfectly uniform. At this stage, the liquid is sweeter, but still relatively thin. The thick texture people recognize hasn't formed yet.
Because the real transformation only begins when factories start removing water from the milk.
Before evaporation begins, the mixture must be carefully preheated. Heat exchangers slowly raise the temperature while keeping the liquid moving. This preparation ensures the mixture behaves correctly inside evaporation systems. The heating also improves the efficiency of the machines used in the next stage. Large networks of stainless steel pipes carry the warm milk through the factory. Every pipe is designed to maintain sanitary conditions and precise temperature control. Industrial sensors constantly monitor flow speed and heat levels. The goal is to deliver the milk in perfect condition, because once the evaporation stage begins, there is very little room for error. This is where the milk will finally start to thicken.
And the machines responsible for this transformation are some of the most fascinating devices in the entire factory.
Inside the evaporation section, the milk enters massive vacuum evaporators. These towering machines are designed to remove water from the milk without burning it. Under normal pressure, milk would need extremely high heat to evaporate, but by creating a vacuum, factories can make water boil at much lower temperatures. This allows moisture to slowly leave the milk while protecting its proteins and sugars.
As the water evaporates, the mixture gradually becomes thicker and more concentrated. Steam rises through the evaporator chambers while the liquid becomes denser. Engineers carefully monitor pressure, temperature, and flow rates throughout the process. By the end of this stage, a huge portion of the milk's water has been removed. The liquid now begins to resemble the condensed milk we recognize.
But even at this stage, one wrong change in temperature could ruin the entire batch.
After evaporation, the thickened milk must be cooled in a very controlled way. If the mixture cools too quickly, sugar crystals can form unevenly. Large crystals would make the condensed milk feel gritty instead of smooth. To prevent this, factories seed the mixture with microscopic sugar crystals. These tiny crystals guide the formation of millions of uniform particles. This process ensures the condensed milk stays silky and creamy. Cooling tanks slowly bring the temperature down, while constant stirring maintains stability. The mixture now has the familiar glossy appearance of condensed milk, but it still needs to be prepared for packaging, because even the smallest contamination could affect shelf life.
Which is why the final stage before packaging focuses on creating a perfectly sterile product.
Once the condensed milk reaches the correct thickness and texture, it moves to the packaging lines. These automated systems operate in extremely clean environments. Metal cans are first sterilized to remove any possible contaminants. The thick condensed milk is then pumped into the cans through precision filling machines. Each can receives exactly the same measured quantity. The cans move rapidly along conveyor belts through sealing machines. Lids are pressed and sealed tightly to lock in freshness. After sealing, the cans are labeled and prepared for distribution. Thousands of cans can be produced every hour in a modern factory. But this still leaves one important question.
What exactly caused the milk to become so thick in the first place?
The secret behind condensed milk is actually a combination of two powerful processes. First, factories remove a large portion of the milk's natural water through vacuum evaporation. This dramatically increases the concentration of milk solids. Second, a carefully controlled amount of sugar is added to stabilize the mixture. The sugar binds with the remaining water molecules. This prevents bacteria from growing and also helps create the thick texture. As water disappears and sugar concentration rises, the milk naturally becomes denser. At the same time, controlled crystallization keeps the texture smooth. Together, these processes transform ordinary milk into a rich, concentrated product. What started as a thin liquid has now become thick, condensed milk. And that's exactly how factories remove the water, control the sugar, and concentrate milk into the product we see inside every can.
And that's the incredible journey of how condensed milk is made inside modern factories. From fresh milk collected at dairy farms to massive industrial evaporators removing water with precision. What looks like a simple can actually involves dairy science, engineering, and extremely careful control at every stage. If you enjoyed discovering how everyday foods are made inside factories, you'll definitely enjoy the next videos in this series. Make sure to subscribe and turn on the notification bell so you don't miss the next factory process breakdown. Because once you start seeing how things are really made, everyday products will never look the same again.